right, class, welcome to the last video of today. So in this question it says, Mari, interesting name, has an ice rink in his backyard. The scatter plot shows the thickness of the ice relative to the temperature. So how thick is the ice as our temperature decreases? Now, this is a funky looking scatter plot because as you can see, our x-axis and our y-axis meet at the origin. So this graph is kind of flipped upside down. This is the x-axis, our y-axis goes up and down like normal. The reason that it looks like it's flipped upside down is because instead of showing us positive temperatures, our temperatures are in the negative, so they're below zero. So if we were to think of this as an entire graph, this is how it would look if I drew out the rest. Okay, well that was a bad drawing. This is how it would look if I drew out the rest. Okay, they've just given me quadrant 4. Okay, so let's talk about what this graph means before we write an equation. As my ice thickness increases, the temperature is decreasing. So this is going to be a negative association, a negative relationship between my ice thickness and my temperature. Okay, so let's go ahead and figure out where we begin, and then what is our temperature per level of thickness becoming? So step 1, it says write an equation in slope-intercept form. So our y equals mx plus b. That's what we always use when we're writing a line, an equation for a line, for the line that is drawn. So they have already drawn our best fit for us, so that's good. Our line of best fit is done. Now, the first thing I want to figure out by looking at my graph is where do I begin? So I begin at 0, 0. So my temperature is at 0 degrees. That's where I begin, 0 degrees. Now I need to figure out my slope or my rate of change, my change in y over change in x. So my x is my thickness, my ice thickness. I'm just going to abbreviate that as my thickness, T-H-I-C-K. And then my temperature is my y-axis. So x always goes on the left, y goes on the right, x goes left to right on my graph, y goes up and down. Now I'm going to use 2 points for my graph. So I'm going to choose my point where I began. That's an easy point. That's 0, 0. Okay, it's always easiest if you can use your beginning point. Now my second point I'm going to use is going to be my point that my line goes through, as that's going to give me the most accurate information. So I'm going to circle this point right here. Now be careful, you might be tempted to write this point as 1, -1, but this is not that point because our 1 value is there. Now because my first value is 3 spaces after 0, that's my first whole. Each tick mark represents a third. So 1/3. 2/3 is my second tick mark, and then 3/3 is my third tick mark, and 3/3 is the same as a whole. So this point right here is 1/3, -1. 1/3, -1. Okay. Now that I've got my 2 points, I'm going to find my rate of change. So to get from 0 to -1, I go down 1 degree in temperature, -1 degree Fahrenheit. Now to get from 0 to 1/3, I go up 1/3 inch in ice thickness. Okay, so here is my rate of change. -1 degrees Fahrenheit. For every 1 degree Fahrenheit, I add 1/3 of an inch of ice. So 1 degree Fahrenheit decrease is 1/3 inch of ice. Now this is kind of a tricky fraction to work with, and it might look a little confusing. So I want to understand how many degrees does my temperature drop per 1 inch of ice. So to figure that out, I'm going to divide the top and the bottom by 1/3. Okay, now when I divide my denominator, 1/3 divided by itself, I get 1 inch. Okay, that's a little easier to work with here. 1 inch. Remember, with slope, I want my denominator to be 1. Now, on my numerator, I've got -1 divided by 1/3. Now, that's not quite as straightforward. So, -1 divided by 1/3. Let's do that on the side. Now, recall, when I'm dividing with a fraction, I keep my first number. I change my second sign to multiplication, keep change, and I flip. I take the reciprocal of my fraction. So 1/3 becomes 3/1. -1 times 3 is -3. So when I have -1 divided by 1/3, I get -3 degrees Fahrenheit for every 1 inch of ice. So what my slope or rate of change means is that for every 3-degree drop, I get another inch of ice. Okay, so now let's go ahead and take all this work and write our equation. So my total amount, my temperature is going to be starting at 0 degrees Celsius. That was where I began. Actually 0 degrees Fahrenheit. And then I lose in 3 degrees for every 1 inch of ice. So that is going to be my equation. Now, if I wanted to simplify this, this would just be y equals -3x. We don't have to write the 0. Okay, so let's now use this equation to make a prediction. So it says use the equation to make a conjecture, a prediction about the 1/3 inches. So what will your temperature be when your ice is 1/3 of an inch? So remember, our equation was y, so the temperature is y, equals -3 times my ice thickness, because x is my ice thickness. Okay, so it says if your ice is 1/3 inch, what will the temperature be? So my total temperature would be -3 times 1/3 of an inch. Okay, so -3 is the same as -3/1. So my answer is -3 over +3, which is just -1. So my final answer is that when I have 1/3 inch of ice, the temperature is -1 degrees Fahrenheit. All right, guys, nice job. So I will have 3 practice questions for you to do, and I will answer any questions you have, of course. These take practice just like anything in math. Give yourself lots of grace, be patient with yourself, and if you get stuck at any point, please let me know. Have a nice night. Sorry, my video got cut off. Have a nice night, guys. I'll talk to you soon, and again, ask if you have any questions.